Whoa, wasn't that cool? I made another intro. I liked the intro from the last video way better, but I know everyone has a short attention span now, so I made something quicker. Speaking of the last video, it did way better than I expected it to do. So I tried really hard to get this video done quickly so you all wouldn't have to wait forever. Was I quick enough? I'm recording this line on the 3rd of June, so compare that to the date this video was posted and make your own decision. With that out of the way, remember this clip? I first got the idea when I was working on a different project. I probably should have made a video on that first, but oh well. Well, that is what this video is not about. Instead, this video is about how I made a speech-to-text to speech program, and probably more interestingly, how I turned this into a Kasane Teto voice changer. Kind of. If you thought my code from the last video was bad, then you're gonna want to brace yourself for this one. So what even is a speech-to-text to speech program? I know the name is kind of a mouthful, but it's pretty self-explanatory. You speak into a microphone and your words are then converted into text. What? Oh wait, you don't have a voice. I'll just voice over for you. You speak into a microphone, "Hi, my name is Jera," and your words are then converted into text. This is often called voice dictation, and you've likely used it before at some point. Text-to-speech is the inverse of this. Instead of your speech being converted into text, it converts text into speech.
Hi, my name is Jera.
As the name implies. So what happens when you combine the two? You get a program that converts your speech into text. "Hello everyone, my name is Jera." Okay, calm down, Jera. But think about it. Maybe this is how we can give you a voice. See, you like that idea, don't you? Where was I? Oh yeah, the text is then read out by a TTS model.
Hello everyone, my name is Jera.
Why would you need this? I don't know. I guess you could use it to talk in games without using your real voice. I didn't think too hard about an actual purpose. But enough of that, let's actually start focusing on the code now. Step 1, we need to convert our speech to text. But how do we do that? Well, we just do what every programmer does and hope someone else has already figured it out. This is the real-time STT Python library, which should do exactly what we need. Oh, and look, it comes with some test code too. Let's try it out. Let's just run this test code. Hello? And would you look at that? We're practically already Kasane Teto. Oh, that's not right. As you just saw, not only does it try to interpret your speech, but also the language you are speaking in. Good in concept, however, it isn't always correct. In the demonstration I just showed, I said, we're practically already Kasane Teto, which, if you can understand what I'm saying right now, you can tell is English. And the program can tell this too, at least up until the point where I said Kasane Teto. At that point, it interprets that as me speaking Japanese, and since it assumes that part is Japanese, then the rest of the sentence must be too. So how do we get around this? Simple. We literally just set the language to English. So now if I say something in another language, say Spanish, ¿Qué hora es? You can see it will try to understand it as English. Hey Jira, can you change the music? Alright, thanks. Ooh, good choice. Okay, great. We've done the first half of the program. Now we just need to do the second half. We need to convert our text into speech. But how do we? Yeah, you already know. We're just gonna use some library. The library we're using this time is called PyTTS-X3. I know the name may look like a bunch of random letters, but if you break it into pieces, you can clearly see it stands for Python, text-to-speech, and then like a funny little face at the end. I don't know. Now let's look at how I implemented it into the code. First, we initialize the TTS engine and then set its words per minute, referred to here as rate. The default rate is 200, but I felt like it was a little too slow, so I just upped it to 250. Then, briefly ignoring this function, we get to this while loop. First, we save recorder.text to a new string called text. After this, we print the string, then pass it to the speak function through threading. Now there's two things I need to explain here. First, why do we save recorder.text to a new variable instead of just passing it to both the print and speak functions? The reason for this is because recorder.text only temporarily holds the transcribed text. So if we told it to print recorder.text, it would be empty by the time the speak function needs it. Or it could be the other way around, where the speak function gets it before the print function. It's literally just a coin toss. So the easiest fix is to just save recorder.text to another variable. After we save it to the variable, recorder.text will be empty, but the variable won't be, so we can still pass it to our functions. Second, what is threading and why are we using it? To best explain this, I'm going to do so via a demonstration. Jira, that means we need you in here. Jira is going to serve the purpose of our computer. Figuratively, don't look at me like that. And for the sake of accuracy, Jira will also be exceeding her frame rate at points. Jira, I want you to draw a leaf and a lightning bolt at the same time. And wow, just like that, she's done. But if we rewind and slow her down to her normal frame rate, you can see what actually happened. First, she draws the leaf, then she draws the lightning bolt. Clearly not drawn at the same time like I asked, but she did it so fast that it looked like she did. And this is how computers work. My request would be the equivalent of 2 tasks, with Jira being the computer. Python code is executed line by line. So in a program like this, with the green line representing what part of the code is being executed, you can see how the computer would run this code. Slowed down for viewing's sake, but modern computers can do this insanely fast. This doesn't seem like that big of a problem, right? I mean, if it can do it that fast, then why does it matter? Because it can't always do it that fast. Jira, draw the Mona Lisa and a leaf at the same time. You can see that even with her increased speed, she wasn't able to do it fast enough to give the illusion of doing them simultaneously. Also, that's not the Mona Lisa, Jira, you just did a self-portrait. To visualize the execution process again, we'll use this program. Unlike the last time, now it takes much longer to execute the next task because it's too busy executing the function. So then, what do you do if you want to have multiple tasks completed at once? You use concurrency. You can achieve concurrency in Python through multiple ways, with one of these ways being through threading. Jira, move over a little. Whoa, look at that. Now there's two Jiras. Original Jira, draw a leaf, and second Jira, draw a thunderbolt. I want you to both do it at the same time. Oh, and you're restricted to your normal frame rate. And wow, no illusion, they actually did it at the same time. That's what concurrency is. It's how you can make Python multitask. Okay, now second Jira, explode. I only want the real one. So it lets us multitask, but why do we need it here? Because if we didn't use threading here, then the while loop would have to wait on the speak function, meaning for however long it has to wait on the speak function, it's not able to listen and transcribe our voice, which isn't good. I mean, you don't want a voice changer that misses words, right? And before other programmers come at me in the comments, I know I probably should have used a different library. As I'm recording this line, I haven't finished the entire project, so hopefully future acrylic switches to async, like I know many of you are about to tell me I should have used. Wow, okay, that was a lot. Let's go finally look at that speak function now. First, we have a simple try except block whose purpose is to stop the event loop if one exists. This way, our TTS is always able to run without having to worry about something else already running. Then, we remove all commas from the transcribed text. This is more of a personal preference, I just felt like it took too long of pauses when there were commas. And these last two lines are what actually makes the program speak. So now that we're finally done looking at the code, let's try it out. Let's just hit run on this program. Hello?
Hello.
See, look at that.
See, look at that.
And boom, it works! Now I know what a lot of you are probably thinking, why was there such a long pause? This is mainly because our transcribed speech is not passed to the speak function until the program detects we're done talking. So how do we make it faster? We don't. We just have to deal with the delay. Yeah, I know, not the answer you wanted, but that's just how it works. Well, we've got our voice changer working, now all we need to do is find a way to play it through our microphone. To do this, we need two things. One, yet another Python library, Pygame, and two, VB audio cable. Another Python library makes sense, but what is VB audio cable? To put it simply, it lets us play audio through our mic. When you install VB audio cable, two new audio devices are created, an output device titled cable input and an input device titled cable output. Trust me, the names will make sense. When audio is played through cable input, the sound is redirected and then played through cable output. You ever wonder how people play music over voice chat? They use this. Okay, so what do we use Pygame for? Isn't that for making games? And you would be correct, it is. But we're only going to be using one part of Pygame, the mixer module. The mixer module's purpose is to load and play sounds. The reason this matters is because we're also able to set what output device it plays those sounds to. This is why we needed VB audio cable. With that out of the way, let's go look at this code I wrote like 2 months ago. First, we initialize our mixer, setting its output device to cable input. Then we have this new function that, as the name implies, just generates a random string. And now we can look at some real changes. Instead of the engine saying the text aloud, we generate a random file name and then save the audio under that name. Then we tell the mixer to load this file and play it. Afterwards, it waits 10 seconds, then unloads the file and deletes it. If all goes to plan, this should now play the TTS through our microphone. On the left side, we have our program, and on the right side, we have Audacity. We have Audacity set up to record cable output, so we'll know our program works if we see anything happen on Audacity. So let's just start recording. You can see, it's not picking up what I'm saying right now. Let's start the program. Hello? How's it going? Let's just stop the program, we can stop the recording, and let's go listen to what it picked up.
Hello.
Okay. What about here?
How's it going?
We've done it. We made a voice changer. Maybe not the typical type that comes to mind, but it's still a voice changer nonetheless. Jira, check your phone.
Yippee.
Yeah, that's to make up for destroying your coat earlier.
What?
Yeah, you remember that clone from the demonstration? Yeah, she was a copy, but her clothes weren't, so that was your actual coat that got destroyed when she exploded.
What is wrong with you?
Yeah, I'm sorry. I'll get you a new one by next video. That voice was alright, but what if we could be someone cooler? Say, Kasane Teto. A couple of months ago, Kasane Teto was added to VoicePeak, a text-to-speech software. That sounds perfect, doesn't it? I mean, our whole program is already centered around text-to-speech, so this should be pretty easy to incorporate. Let's just see how much it costs. Jira, how much is that in USD? Okay, well, the last video did pretty good. Let's just use some of the revenue I made from that. Oh right, I'm not eligible for monetization yet. Okay, what about Synth V Teto? Jira, USD? Okay, I still don't have that money. What are my other options? Utau Teto? How much does that one cost? That's all I needed to hear. So let's go download UTAL, except we're not going to do that because it sucks. I tried using UTAL, but for it to work you have to change your system settings so the Unicode can be rendered properly, and then once you actually get it working, it's just a very dated program. Instead, we're going to be using OpenUTAL, an open source alternative to the original UTAL software. OpenUTAL projects use the USTX file type, which, upon closer inspection, are just plain text. Skimming through the file, you can find what part stores the lyrics. Here we have a simple template I made. This isn't the whole file, there's a bunch of stuff above this, but that's not important right now. This line here determines what our Utaloid is going to say, with our Utaloid being Kasane Teto. So whatever is right there is what Teto will say. So let's go look at some code. We had to shave quite a bit off from the last version, but that's because we're basically starting from scratch. Here, we declare a variable, search phrase, and set its value to the string replace me, which you should remember is what the lyric is set to in our template. Skipping past some old lines, we create a random file name and then pass that name, search phrase, and transcribe text to a function. This function is...
You just did a whole lecture on concurrency. Why is it not being used here?
I don't remember. Stop asking questions, Jira. As I was saying, this function is what creates our USTX file. The whole function is encased in a try except block. The whole purpose of it is to make sure the program doesn't break if it runs into an error. These first two lines open our template file and save its contents to a variable. Then, we search through those contents to find our search phrase, replace me, and once it finds the phrase, it replaces it with our transcribed text. And finally, we save our updated content in a temp folder under the random file name we generated. So let's try out some phrases. Jira, is she up and running?
Yep.
Okay, great, thanks. Does this work?
Does this work?
Okay. Hi.
Hi.
Oh, well that's a little odd. As you just saw, when trying to get Teto to say something short, like hi, she stretches out the word much more than she should. And that's all because of this value in our template file. This value determines how long it will take Teto to finish saying our signed lyric. This value is in milliseconds, so after a little Jira-powered conversion, we can see that it's currently set to have Teto take 1.5 seconds to finish saying our lyric. This isn't always noticeable. Think back to that first line she said. Or don't think back, I'll just play it for you.
Does this work?
Doesn't sound that bad, right? Well, that's because you just got lucky and the words happen to fit all right within the allotted duration. A little lost? Let's visualize it. This bracket represents the 1.5 second duration. Let's start with our first phrase. Does this work? You can see it fits in the bracket pretty well, but it does have to stretch itself a bit, which is reflected in the audio.
Does this work?
Let's try our second phrase. Hi. Now you can see that the text has to be stretched a lot more here to fit into the bracket, which is why the audio sounds like this.
Hi.
So far we've only had it stretch, but it will also squish. Let's try out a new phrase. I went to the store today, it was really fun. And wow, look at the text, you can barely read it, it's so squished. And if you're curious, this is what that sounds like.
I went to the store today, it was really fun.
So how do we make it sound normal? We just do the opposite. Instead of having our lyrics match our duration, we have our duration match our lyrics.
But how do we do that?
I was just getting to that, Jira. Before we look at our updated code, let's first look at our new templates. Our template is now split into two files, template.ustx and word.txt. Why aren't they the same file type? Because it doesn't really matter here. The contents of both files are just plain text, and the program is set to always read them as such. So theoretically, you could change the file extensions to anything you want, as long as the contents stay unchanged. But just for consistency, let's go ahead and change template.ustx to template.txt. Template.txt is all that extra stuff I skipped showing you last time, which I'm going to do once again, because it's just like project settings and stuff, but I will show you word.txt. Word.txt should look familiar, because it's the portion of the template file we went through earlier. Take note of some of the values, like dur__, or pos__. Those are our search phrases, so we can easily replace them in our program later. So if template.txt and word.txt just combine to make our original template file, why split them in the first place? Because having part of it split into word.txt allows for us to easily make new segments. I'll try and visualize it. We start with, Jira, what are you doing here?
I want to be on screen again.
But I don't have anything for you to do in this scene.
I don't care.
Okay, just like, sit there while I do this. I'll make sure there's something for you to do soon.
Yippee.
We start with our template.txt file and then follow it with our word.txt file. Now, if we want to make Teto say another word after that, it's as simple as adding word.txt again, which we wouldn't be able to do if it was just one file, because then we'd end up re-adding the project settings. Okay, hopefully that makes sense. Let's actually look at some code now. I know it looks like there's a lot going on behind me, but we've got to go in order, so just give me a second. This part is basically the same as the last version, with the only difference being we don't pass search phrase to the function anymore, because we don't have a search phrase to pass. You'll see why that is in a minute. This is where most of the changes were made, so let's go through them. First, we split our transcribed text into a list called words. I feel like that's pretty self-explanatory, but not everyone here programs, so I'll briefly explain. We start with a string like this. When we split the string, it gives us a list of all the words in that sentence, each with its own spot. As you might have already noticed, lists in Python start at 0 rather than 1. Keep that in mind for later. Now, if we want to grab a specific word from that sentence, all we have to do is tell the program which spot in the list we want to look at. After that, we open our two template files and save the contents of each one to its own variable. We then make a new variable, updated content, and set its value to the contents of our first template file. Now we really start doing stuff. First, we open our output file so we can write to it later. Then we create a new variable called total DUR and set it equal to 0. I'll explain its purpose in a second. Here we start a for loop so we can go through each word in our list. Len words gets the length of our list, so if there are 5 words in a list, then its length would be 5. The variable I in this for loop is a number that increases by 1 every loop, stopping before it reaches the number we specified in range. However, this doesn't mean that if the range is set to 5, it will only do 4 loops. Remember, we start at 0, not 1. So with a range of 5, I would go 0, 1, 2, 3, 4, still getting us 5 total loops. The first thing we do in this loop is create a new segment by copying speech underscore template to the appropriately named segment variable. Then we search for the phrase POS underscore underscore and replace it with total DUR. The total DUR variable is how we determine where each segment needs to be positioned. If I have one segment at the very start that lasts for 500 milliseconds, then my position for the next segment would need to be 500 so that it'll start right after. If that next segment lasts for 700 milliseconds, then to add another segment after that, I would have to position it at 1200, the sum of the duration of the first 2 segments. Every time we calculate the duration for a segment, we then increase total DUR by that same amount, allowing for everything to be positioned correctly. With that out of the way, the next thing we do is search for the phrase word underscore underscore and replace it with the word in our list at the spot I. A little confusing? Well, it shouldn't be, you should be paying attention. But I did tell Jira I was going to give her something to do, so she can visualize it for you.
To get a word from the list, we have to specify what number it can be found at, and I is a number that increases by 1 every loop. So on the first loop, getting the word from the list at spot I would return sub because I is currently equal to 0. On the second loop, it would return 2 since I would now be equal to 1, and you get the idea. The third loop would give you the, and the fourth and final loop would give you channel. So, how did I do?
That was actually pretty good. Nice job, Jira. After that, we then remove punctuation from our word. This doesn't remove all punctuation, just the ones that are most common to appear when our speech is transcribed. Why do we remove punctuation? Well, it's because of how this next line is set up. This is how we calculate the duration for each word. Len words I gets the length of our word, which we then multiply by 100. 100 is how many milliseconds we are allocating for each letter. You can make this value higher or lower, depending on how fast you want her to talk. Using 100 as our value, this would mean that a word like book would be given a 400 millisecond duration, 100 milliseconds for each letter. Punctuation adds towards the word's length, even though it isn't pronounced, which is why we removed it. If we didn't make this change, then something like the word don't would be given a 500 millisecond duration instead of 400, in turn dragging out the word. Okay, that makes sense, but if we were going to remove punctuation, why not do it before replacing word underscore underscore? Because we still need the punctuation to clarify how the word should be pronounced. If we were to remove punctuation before replacing word underscore underscore, then instead of saying don't, Teto would say don't. After we've calculated the duration, we then search for the phrase DUR underscore underscore and replace it with that. Next, we increase total DUR and finally end our loop by adding our segment to updated content. After the loop has run through the entire list, we add one last line to our file. I don't really know what it does, but it was in my original template file, so I figured we'd need it. Following that, we write everything to our output file. Okay, we're finally done looking at the code. That took forever. Let's go try it out. Jira?
Yep, she's on.
Oh, okay. Hi.
Hi.
How's it going?
How's it going?
See? That worked pretty well, but she's a little monotone. What do we do about that? Well, the logical thing to do would be to try and capture our pitch as we're speaking and use that. Unfortunately, I am lazy, so I took a simpler route. A total of 2 things changed between this and the last version. We changed one line in our word.txt template file and added one new line to our program. Instead of tone being set to 63 in our word.txt file, it's now set to tone underscore underscore. Right before we add our new segment to updated content, we search for the phrase tone underscore underscore and replace it with a random number from 60 to 70. Is this the best way to do it? No. Does it sound at least a little more human? Well, let's go find out. Hi, how are you? Jira, why is she not working?
Because she's not on.
What? Then turn her on.
Okay, I guess.
Hi, how are you?
Hi, how are you?
I am very hungry.
I am very hungry.
Yeah, that's good enough. And we're done. We have a Kasane Teto voice change.
No.
Ugh. What, Jira?
You still have to make it play through the microphone.
Ugh. Why'd you have to remind me? Wait, Jira, how are you talking right now?
I swallowed my phone.
Why would you do that?
Because now it looks like I'm talking. See? John Madden.
What is wrong with you? You're gonna get sick and have to throw up later.
Nuh-uh.
Whatever. When it comes to trying to play this through a microphone, that's when you start to run into some issues. My first idea was to see if I could somehow render the USTX files using the command line. What's that mean? Doesn't matter, because I couldn't do it. But wait, OpenUTAU is open source, meaning I could just make changes to the code myself. So, why don't I just add command line support? Yeah, that didn't happen either. I had no clue what I was doing. That leaves us with the classic option of just automating the program's UI. Let's go look at this code that took me all of 5 minutes to write. After our function call to replace in file, we then pass our file name to a new function, play. And there's really no need to go into depth about what happens here. We get the file's location, open the file, play the file, then delete the file. If you wanted to save some time in this function, instead of using the full file path to get our file, we could just use the file name, but this would require OpenUTAU to default to opening in our temp folder. This on its own won't make it play through your microphone, and VB audio cable won't help us here either. This program only works if you are always looking at OpenUTAL. Not you yourself, but like the computer, you know? So if you tried to use this while playing a game, it just wouldn't work. What's the solution? Another computer. Here's the setup. We plug our microphone into computer 2, which is going to be running our program and OpenUTAL. Then we plug one end of a capture card into computer 2 and the other end into computer 1 so we can get the audio and video output on our main computer. We don't actually need the video output for anything, I just figured I'd mention it. And that should be all you have to do. From here, you can run the program and then focus into OpenUTAL on computer 2 and just set your microphone on computer 1 to your capture card. Now, it's hard to capture footage for this part of the showcase because I'd have to record 2 computers simultaneously, so instead I'm just going to be doing it on one computer. Just know though that that setup does work, it's just really hard to record it. On the left I have our program pulled up, and on the right I have OpenUTAL pulled up. So let's go ahead and start our program and tab into OpenUTAL. Hi, how are you?
Hi, how are you?
I'm doing good.
I'm doing good.
How about you?
How about you?
And boom, that's it. To answer Jira's earlier question, why aren't we using concurrency? Because, what's the point? OpenUTAL can only use one at a time, so there's not really a reason to try and multitask. We're just gonna have to wait anyways. Could this program be improved? Yes. I actually had a completely different idea for an approach to this that I didn't go through with. Why didn't I? Because this video's too long and I wanna go home. If you want me to make a part 2 to this video, let me know, and maybe I will. And hey, if I actually make any money from this video, I can try my original idea and make a version that uses VoicePeak. Speaking of, this should be the upload that makes me eligible for channel memberships, so if you see a join button down there, hit it. I would tell you the benefits, but I don't know what they are yet. I also have a Discord server now. It's kinda bare bones, and there isn't even a general chat, but hey, look at this. Whoa, isn't that cool? It's a progress tracker for the videos. And yeah, that's pretty much it for that. You should join though. With that out of the way, I hope you enjoyed the video. Everybody say thank you Salami for making the visuals.
Thank you, Salami.
I honestly was going to scrap this video because I wasn't happy with how the program turned out, but I was in too deep by that point to quit. Jira, come here. You got to say goodbye to the audience. Oh, what happened to you? Oh, I know. See, I told you that was gonna make you sick. What happened to your phone? And now your phone is broken too. So much for giving you a voice. Just wave the audience goodbye, Jira.